All right, today we're going to be learning how to simplify radicals, also known as square roots. Note that right now we're only going to look at how to simplify something like square root of 75, and we won't be using any variables. So we will not be looking at how to simplify something like 75 squared or x squared or something like that. So that'll be for another later video. All right. So let's start. So let's look at exactly how to simplify. First, let's start with something like square root of 9, right? So if it's a perfect square, the square root function just says the square root of 9 is 3. Okay, we could do that with square root of 16, square root of 25. The problem is, what if we want to simplify something like square root of 18? Okay, now we could approximate that. We could use our calculator and come out with an exact decimal. We could, ballpark and say, well, square root of 18 is between the square root of 16, and it's between square root of 25. So it's got to be bigger than the square root of 16, but smaller than square root of 25. So we could say it's something like around, I don't know, like 4.2 or something. But that's an approximation. What if we want to keep it exactly correct, but simplify it? Okay. The trick is we break this up into a product. Okay, and I'll write this out. We want to break this up. Let's turn to pink. Okay, you want to split this into the product of a perfect square and leftovers. Okay, so let's do that. We're going to split this up into, let's start with square root of 9 times square root of 2. That's the perfect square that we can split out in a product of square root of 18. So we get 3 root 2, because the square root of 9 is 3, and the square root of 2 we can't do anything with, so it just stays like that. Now, a couple of you being, well, can we split up a square root? Okay, well, let's just off to the side. I'll do it on another page. Is let's just look at, can we take the square root of a single number and split it up? Because obviously you can't split up everything. So let's look at why we can or can't do that. Now, the square root of something like 18 is actually the same thing as 18 to the 1/2 power. So it's just like 18 to an exponent. So the question is can we say that like AB squared is the same thing as A squared B squared? Like, can we, with an exponent, include it in one clump with parentheses, like here on the left, or have it separately have that exponent? That's the same thing as square root of 9 times 2 becoming square root of 9 times square root of 2, right? Those are analogous. So can we do that? Well, of course. So the reason this is so much easier is because this is a single term. This is a monomial. So since it's a single term, we can write this out. So A times B, that's AB, and squared is times another AB times itself. But that's just one clump of multiplication. So A times B times A times B. No multiplication is bigger, more important than the other. And we know with multiplication, we can always switch the order. Like 3 times 4 is the same as 4 times 3. So we could just switch this order here and say, okay, well, that's A times B times B. So of course that's A squared times B squared. So we can do that for sure. Same thing here. We could say A times B times B, switch the order, and we could get back there. So these are equivalent. It's when there's a plus sign and it becomes a polynomial that everything gets harder. Okay, so let's go back to the problems we work on. Let's try a few. Okay, so let's simplify something like the square root of 75 that we mentioned earlier. All right, so if you've got a good number sense, you're comfortable with, like, you've got some perfect squares memorized, you might see one right away. But if not, you can always go off to the side and just factor this out and say, okay, well, this is, I don't know, this is what? 5 times 15, which is 3 times 5. So if I factor this in terms of its primes, I factor as much as it can be, it's 3 times 5 times 5, or 3 times 5 squared. So when you factor it, you're able to see, oh, look, there's a perfect square in my number. 5 squared being 25, so I could write this as 3 times 25, where I know this is a perfect square, because I see that prime has a partner. So over here, when I want to simplify square root of 75, I'm going to write it as the square root of 25. That's the perfect square. Times the square root of 3. And again, in pink here, I'm going to say this is the perfect square. I'll write it first just because when we simplify it, it's good to have the coefficient out in front rather than after the root. Wouldn't be wrong the other way, but there is some ambiguity of where the square root ends. Okay, so the perfect square will pull out, and then this is just whatever's left over. All the primes that didn't have a partner. Okay, so that ends up being equal to square root of 25 is 5 times, and square root of 3 we can't do anything with, so 5 root 3. Okay, let's do maybe one or two more. So let's see, simplify. Let's do square root of 45. Again, I don't see a perfect square. It goes in right away. I could guess and check, like 1 squared is 1, that doesn't help. 2 squared is 4, so does 4 go into this? No, it's not an even number. Does 3 squared, 9, go into this? 9 does go in this. So guess and check worked out that time. Or again, I could have just factored this. So 45 is 3 times 15, which is 3 times 5. So this is 3 squared times 5. And oh, look, there's my perfect square. So I'll split this up to be square root of 9 times square root of 5, which is 3 root 5. Okay, so now let's actually go over to IXL and actually practice. Okay, so here's square root of 20. We can write this as, well, let me pull up my pen here. The square root of a perfect square 4 times its leftovers. 4 times 5 is 20. So we get a 2 root 5. So let's go down here. And, oh, I didn't click on it. Let's get this. And we'll write our 2 root 5 here. Perfect. Okay. All right, square root of 75. We actually did this one earlier. So square root of 75 can be split into square root of 25 times square root of 3. So that's 5 root 3. Let's go ahead and submit that. Okay, square root of 27. So off the top of my head, let me think. I could try my perfect squares. So 1, 4, 9, 16, 25. I could go down the list here. But I do notice that 9 goes into this. So square root of 9 times, oh, I don't know why I put a comma there, times square root of 3. So that's 3 root 3. So let me go ahead and enter that. All right, let's try another one. Square root of 12. Okay, so again, let's check. Does 1 go into it? Does 4 go into it? 4 does. So square root of 4 times square root of 3. That's 2 root 3. Again, I'm looking for those perfect squares. Okay. Ooh, a square root of 18. So again, let's see what perfect square goes in there. So that's 4 doesn't go into that. 9 does go into it. So that's square root of 9 times square root of 2, or 3 root 2. Okay. Oh, now it's getting a little harder. So there's this floating 9 out there. Well, let's just simplify the square root of 45 first. Okay, so square root of 45 has a 9 out front, but we'll come back to that. So let's see, we did this one earlier. I know that 1 goes into, of course, 4 does not, 9 does. So let's try pull out that 9. And we're left with 3 root 5. Now the question is, what sign was right here in between the 9 and the 45? Well, if there's no sign written there, just like if I write 3x, we're talking about multiplication. So that was 9 times this. So I'm going to write 9 times out front. 9 times out front. So let's simplify this 9 times 3 into 27 root 5. And that's what comes out. So we get 27 root 5. Okay, let's just do one last one here together. So again, we got 2 root 18. I'll simplify that root 18 to be root 9 times root 2. And I'm going to keep this 2 here. So now this is 2 times 3 times root 2, which comes out to be 6 root 2. Okay, I'll enter that. Perfect. So I hope you enjoyed that video on how to simplify a square root. This will help you as we get into Pythagorean theorem.